Hello, welcome in my channel Web Geographia. I am Kamal Sharkar. So today I am discussing about the descriptive statistics, and this is the second part. So in the first part I have already discussed the different types of data, that mean primary data, secondary data, their collection methods and the classification of data, then data tabulation and how types of statistical series, and finally I have discussed the individual series and their formation, that mean according to serial number or simple arrangement of data. So today in this video I am going to discussing about the frequency distribution table. So we have already learned that the frequency distribution table is of two types. One is discrete series and another is continuous series. So today in this video I am discuss the discrete series. So first we should know what is discrete series. So a discrete series represent the discrete variables, that means when it is represented discrete variables it is called as discrete series. So in this slide I have shown the different types of frequency distribution series, that means discrete series and continuous series. So continuous series can be divided into 5 categories, that means exclusive, inclusive, open and mid-value series, cumulative frequency series. So cumulative frequency series again are divided into 2 categories. One is less than series and another is more than cumulative series. Here in this slide I am showing how to form a discrete frequency distribution table. So the process of preparing this discrete series is very simple. Here actually what to do, we have just to count the number of items and their particular values, how many times they are repeated, and put the values in frequency and using the talisman. So this is the simple way to form a discrete frequency distribution table. So here these are the variables which is already given in our question. So the minimum value is 1 and the maximum value is 5. So we have written here 1 to 5, and just we have to count how many times this 1 is repeated. So if you count like 1, 2, 3, 4, 5, 6, 7, so 1 is repeated 7 times, and these are the tallies. So up to 4 the tally will be vertical and the number 5th is actually oblique, and after that again vertical line will be placed. So in this way we are using the tally mark, and using these tallies we can easily count the frequency number. So this is a simple discrete frequency distributions table, and in this table you can easily find out the frequency of discrete variables. So now I have given this question for your homework. So on the basis of these variables you can prepare a frequency distribution table, that means discrete frequency distribution table. So using this variable you can prepare a discrete frequency distribution table. So here I have given the various types of continuous series and their examples. So this is first one is exclusive series. So exclusive series mean you can see here this is 20 and this one is 20. So both are 20. So suppose one variable actually that is 20, so where it will be included, that is the question. So if it is 20 then it will be counted here, not here, because here it will be included. That means here it is actually excluded, and that's why the series name. So next one is actually inclusive series. So in inclusive series you can see the range is 0 to 9. That means if a variable is 10 then that will be counted here, and if it is 9 then that will be counted here. Next is actually Openm series. So in the case of Openm series you can see the ends are open condition, but otherwise they look like a exclusive series. Then is actually mid-value series. So mid-value series mean the middle point of this range. So if the lowest value is 10 and the highest value is 20, so the midpoint is actually 15. So we can calculate in a simple way. If we add these two values, that mean 10 plus 20 and divided by 2, then we will get its mid value, that is 15. So in this way we can calculate the mid value series. Next is actually less than cumulative frequency series. So in the case of less than cumulative frequency series, we can convert this series from this exclusive one. So here you can see these are the values. These values that represents actually less than side, whereas this side represents actually more than side. So here it is 20. So 20 mean actually here it is less than 20 but more than 10. So in this way this side totally represents the more than side. So if it is less than 20, the frequency is 6. But if it is less than 30, so less than 30 mean already less than 20 and less than 30. That means for less than 30, both frequency will be calculated. Like 8 plus 6, it will be 14. And next one, less than 40 mean all these frequencies. So it will be 19. Okay. So in this way, you can easily calculate the more than cumulative frequency. So this side represents actually the more than side. So more than 10 mean all these frequencies, but more than 20 mean this one, and more than 30 mean only 5. So in this way, more than 30 mean 5, then 20 mean 5 plus 8, and more than 10 mean all these one. Okay, so in this way we get here 19. Okay, before going to discuss the continuous frequency distribution table, first we should know some basic terminology. So first one is actually class. So what is class? No, the class limits are the lowest and highest class value, and that can be included in a class. For example, if we see in the previous table, here this is a class. So here actually this one is the lower limit of the class and this one is the upper limit of the class. That means no value that is less than 10, less than 10, that will be included here, or no value that is more than 20, that will be included here. So this is the actually class. So there is a formula to find out this class, and the formula is Sturge's rule and general rule. If we follow the Sturge's rule, then the formula is k equals to 1 plus 3.322 log n, where n is the number of total items or total number of variables. So in this way you can easily find out the total number of class or groups. And another formula is general rule, that is if you want to find out the class, then you can follow in these rules also. So here I am showing you what is the class limit. So these are the class limit, that means 10 and 20. This is actually lower limit, this one is the upper limit. Next is actually class interval. So the class interval is the difference between upper limit and the lower limit of a class. That is known as actually class interval. For example, if we see that is here it is actually 10, that is the lower limit of the class, and the upper limit of the class is 20, then the class interval is actually 20 minus 10, that means 10. So that is the class interval. So if we format, or if we want to form a continuous series, that means exclusive or inclusive, in such cases we have to find out the class interval, and this is the formula. That means it is expressed by I, and I equals to L minus S by K. K mean actually the class, and class, the formula of class is actually 1 plus 3.322 log n. So if we put the value of largest item here and the smallest item here and divided by K, then we will get easily the class interval of a class. So here the reference books name, you can follow these books and you can purchase also these books. And finally, thank you for watching, and my next upcoming videos is same thing, that is descriptive statistics, but it's third part.